Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So we have a 4 kilogram box is on a frictionless 35-degree slope and is connected via a massless string over a massless frictionless pulley to a hanging 2 kilogram weight. So this mass here is 4 kilograms. Okay, so what is the tension in the string if the 4 kilogram box is held in place so that it cannot move? If it's held in place and cannot move, that means it is in equilibrium. So let's focus on box A because it's simpler. So the sum of all the forces in the y direction should be 0. So T should be equal to M A G. So this is A, that's B. So the tension is 19.6 newtons. So for part B, if the box is then released, which way will it move on the slope? So we need to find which forces are higher. So the force on box B, it pulls to the right at 19.6 newtons, and it pulls to the left at mbg sine of theta. So we have mbg sine of theta, which is 4 times 9.8 times sine of 35 degrees, is 22.51 newtons, and this is left, and this one is right. So for part B, it is going to go left down the slope. Part C, what is the tension in the string once the box begins to move? So once the box begins to move, you have mb times acceleration is mbg sine of theta minus t. So the sum of all the forces is equal to the mass times the acceleration. Ma times the acceleration is equal to t minus mag. So we can solve both of these by plugging in for the tension. So this is Ma plus Mb. So adding these equations, T will cancel, is Mbg sine of theta minus Mag. So solving this for A, we're going to divide by M1 plus M2. So A is equal to G M1 sine of theta minus M2 over M1 plus M2. So we can use this to solve for T, where T is equal to M2, and then it will be the acceleration. Whoops. Ones and twos, A's and B's. Sorry about that. So this is MB sine of theta MA plus MB. So MA, this mass is going to fall down with the acceleration g plus a. So we have this for g, we know all of these values. We can plug this in and we get t is equal to 20.51 0.56 newtons.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Hi, here in this given problem, there is a rough inclined plane making an angle of 20 degree with the horizontal, like this. The book kept over this inclined plane here. This is an ideal pulley, the cord passing over the pulley attached with the book, and then finally there is a mug, coffee mug, attached at the other end of the cord. Mass of the mug is small m, so its weight mg acting vertically downward, tension T in the string upward, and here this is the same tension T over here also. If the mass of the book is capital M, its weight mg acting vertically downward, so the two components of this weight, one of the component normal to the inclined plane mg cos 20 degree, and another component down the inclined plane mg sin 20 degree, normal of the inclined plane at the book, that is n. So when the book will be pushed upward over the incline, force of friction will be acting over it in downward direction, kinetic friction. Now the given data: mass of the book 1.0 kilogram, mass of the coffee mug 500 gram, or we can say 0.500 kilogram. Coefficient of static friction 0.50, coefficient of kinetic friction 0.20. In the first part of the problem, we have to find the distance moved by the book up along the inclined plane before coming to rest. It is given an initial velocity Vi is equal to 3.0 meter per second in upward direction. Finally, it comes to rest. Now to find the distance, we should find acceleration in its motion, for which, using free body diagram of the mug, as the book will be moving up but the motion is retarded, means downward force should be more. Similarly here also, the downward force means mg acting over the mug, that should be more than T. So for the free body diagram of the mug, mg minus T, that should be equal to m into A. We can make it equation number 1, and then taking free body diagram of the book, total downward force acting on it, tension T in the string plus component of its weight mg sin 20 degree plus force of kinetic friction mu k times normal reaction n, which is equal to mg cos 20 degree, and that should be equal to m into A. That is equation number 2. Adding equation 1 and 2, tension T will be cancelled, leaving behind small mg and plugging in the known values also. For small m, that is 0.500 kilogram into 9.8, plus for capital M 1.0 kilogram into 9.8, and here we are taking this mg as a common out, so leaving inside sin 20 degree plus mu k means 0.20 into cos 20 degree, and in the right hand side that will be the addition of masses of the mug, and taking this acceleration as a common out, it will be 1.0 plus 0.5. okay, so this 1.5a will be given by 4.9 plus 9.8 bracket 0.342 plus 0.188, and it comes out to be equal to 10.1. So acceleration in the motion of the book acting in downward direction means actually it will be the retardation, and it is calculated to be equal to, that is 6.73 meter per second square. So finally, for the retarded motion of the book up above the incline, using third equation of motion, Vf square is equal to Vi square minus 2As, this is 0, is equal to square of 3 minus 2 times of A, which is 6.73, multiplied by S, which is missing, we have to find it, so that will be given by 9 divided by 2 times of 6.73, and it is calculated to be equal to 0.668 meter. So the distance moved by the book up above the incline, 0.668 meter, or we can say 66.8 centimeter. Answer for the first part of this given problem here. Then in the second part of the problem, we have to check, after coming to rest over the maximum height over the inclined plane, whether the book will stay there or will start sliding down. So if book stay there at the highest point, in that case, looking at the free body diagram of the mug, T will be equal to mg, tension in the string, that will be equal to mg. So downward force acting on the book, F, that will be equal to tension T plus mg sine 20 degree, means 4.9 plus 1 into 9.8 into sine 20 degree, which is calculated to be equal to 8.25 Newton. So as the book will be having a tendency to move down, so upward force of friction Fs, that will be equal to mu s into normal reaction mg cos 20 degree, means that is 0.50 into 1 into 9.8 into cos 20 degree, and it is calculated to be equal to 4.6 Newton. But it is clear that downward force is more than the force of friction.
Humpback whistle? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so you have a 2-kilogram cable car descends a 200-meter high hill. In addition to its brakes, the cable car controls the speed by pulling an 1,800-kilogram counterweight on the other side of the hill. Rolling friction of both the cable car and the counterweight are negligible. Okay, so let's start with a free body diagram. You have M1G. This is M2G for the weight. This is N2. N1. Tension, tension, and when we're looking on the left side, our coordinates do that. And we're looking on the right side. Our coordinates are going to do that. Okay, so let's start on the cable car. So you have the force is equal to m1g sine of 30 degrees minus m2g sine of 20 degrees. So when you're talking about in the x direction, so we get this from analyzing the tension. So we have m1g sine of 30 degrees minus the tension minus the force equals 0. And we also have the tension minus m2g sine of 20 degrees equals 0. So that's the force. So we get the force is 3,766.76 newtons for part A for the braking force. B, one day the brakes fail just as the cable car leaves the top of the downward journey. What is a runaway car speed at the bottom of the hill? Okay, so first to find the speed, let's find the acceleration. So Newton's second law, m1 times the acceleration is equal to m1g sine of 30 degrees minus the tension, and m2a is equal to the tension minus m2g sine of 20 degrees. So this gives us the acceleration is equal to g m1 sine of 30 degrees minus m2 sine of 20 degrees over m1 plus m2. So we have the velocity is 2a delta s, or in this case it's going to be h. So looking at our figure, we have that sine of 30 degrees is equal to h over L, or h over delta S. So delta S is equal to h over sine of 30 degrees. So we have all of the information to solve for the velocity. So this is the square root of 2a delta S, which is 28.17 meters per second.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so we have one car ascends as the other descends. The cars use a two-cable arrangement to compensate for friction. One cable passing around a large pulley connects the cars. The second is pulled by a small motor. Suppose the mass of both cars with passengers is 1,500 kilograms. The coefficient of rolling friction is 0.02, and the cars move at a constant speed. What is the tension in the connecting cable and the cable to the motor? So let's find the tension in cart A. So the sum of all the forces in the y direction is equal to 0, which means the normal force is equal to mg cosine of theta. M is 1500. We know G, theta is 35 degrees. So N is 12,053.82 newtons. The sum of all the forces in the x direction are equal to 0. So you have the tension is equal to mg sine of theta minus mu r mg cosine of theta. Plugging in these values, we get the tension is 8199.10 newtons. Part B, we want the tension in the cable to the motor. So let's look at part B now. So the sum of all of the forces in the y direction give you the normal forces mg cosine of theta. So you get the exact same normal force as above. The x components are what's different here. So T of the motor is equal to mg sine of theta plus the frictional force, mu r mg cosine of theta, and then minus the tension in the other cable. Again, we have all of these values. So T sub n is 482.15 newtons.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
A house painter uses the chair and pulley arrangement as the figure shown in your textbook to lift himself up the side of a house. The painter's mass is 70 kilograms and the chair's mass is 10 kilograms. With what force must he pull down on the rope in order to accelerate upwards at 0.2 meters per second squared? Okay, so Newton's third law. If he pulls the rope with a constant force, then the tension is equal to that constant force. So that's from Newton's third law, action reaction. But from Newton's second law, you have the mass of the painter plus the mass of the chair times the acceleration of the system is equal to the force plus the tension minus the weight. So solving this for the force, this is 2 times the force. So this gives us the force is mp, mc, a plus g over 2, which means the force is equal to 400 newtons.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so you have a 70 kilogram tightrope walker stands at the center of a rope. The rope supports are 10 meters apart and the rope sags 10 degrees at each end. The tightrope walker crouches down, then leaps straight up with an acceleration of 8 meters per second squared to catch a passing trapeze. What is the tension in the ropes as they jump? So, Newton's second law. The normal force should be equal to the mass times the acceleration plus the force due to gravity, which is mg. So the normal force, we know the mass is 70 kilograms. They told us the acceleration is 8 meters per second. G is 9.8 meters per second. So the normal force is 1,246 newtons. So there are two tensions, both in the y direction, both pointing upwards. So the net force in the y direction is 2 times the tension sine of 10 degrees minus the normal force. This should be equal to 0 since it's in equilibrium. So that means the tension is N divided by 2 sine of 10 degrees. So this makes the tension 3,588 newtons.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Hi, here in this given problem, first of all, there is a wedge having angle of inclination theta over this wedge. The mass of this wedge, that is M2, and over the wedge, this is a block having mass M1. A force is being applied, a horizontal force is being applied to the right side, acting towards right over the left side of this wedge, horizontal force F. Now weight of this block M1G acting vertically down. So there will be two components of this weight because this angle is also theta. So component of the weight perpendicular to the inclined plane M1G cos theta, and component along the inclined in downward direction M1G sin theta. Okay, now first of all we find net acceleration in the motion of the system A using Newton's second law of motion. Total force applied on the system F, that will be equal to product of total mass of the system M1 plus M2 and acceleration. So this acceleration will be given by F divided by M1 plus M2. Now the force applied by the wedge surface over this block, suppose this is F, small f, so the same force will be applied by the block on the surface of the wedge F. So in order to find this F, using free body diagram of the block only, it is experiencing force F towards right, and that force should be equal to M1 into A using Newton's second law of motion. Means this is M1 multiplied by F divided by M1 plus M2, and same force is acting on it towards left also. So this force may be resolved into two components because this angle is also theta. So component of this force which is acting towards left, that will be horizontal component will be force is itself horizontal, so the component along the incline, that will be F cos theta, and perpendicular to the incline F sin theta. Now as the block neither moves up nor it moves down, so we can say the force acting on it in upward direction F cos theta that should be equal to force acting on it in downward direction, m1g sine theta. So for this force small f, this is m1f by m1 plus m2 cos theta is equal to m1g sine theta. Cancelling this m1 from both the sides, f comes out to be equal to m1 plus m2g sine theta divided by cos theta, or we can say expression for this force, that is m1 plus m2g tan theta, which is the answer for this given problem here. Thank you.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so you have 100-kilogram basketball player can leap straight up in the air, a height of 80 centimeters. So let's start by looking at some free body diagrams. So we have our x and our y axis. Oops. There we go. So we're going to do 3 free body diagrams. One of the player standing and jumping, one of the player off the floor, and one of the floor itself. So the first one is going to be the player standing and jumping. So there is a normal force of F and P, the floor to the player. You also have the force due to gravity. So then we're going to look at the floor. The floor is being pushed on from the person. And then the player on the floor is just experiencing, the player off the floor, is just experiencing the force due to gravity. Okay, so part B, the net force. Is there a net force on the player as he jumps? How can that be? Explain. So if he is standing at rest, then his net force is equal to 0. Since his net force is equal to 0, he is not accelerating. So the reaction from the normal force will exceed his weight, and that is how he's able to push himself upwards and leave the floor. So part C, with what speed must the player leave the ground to reach a height of 80 centimeters? So we have the expression, the velocity is the square root of 2gh. We know 2, we know g, we know h. So the velocity has to be 3.96 meters per second. For D, what was his acceleration assumed to be constant as he jumped? So we can find the acceleration with v squared equals 2ay. So a is equal to v squared over 2y. We just found v. We know y is 60 centimeters to 0.6 meters. So the acceleration is 13.07 meters per second squared. Okay, part E. Suppose the player jumps while standing on a bathroom scale that reads in newtons. What does the scale read before he jumps, as he is jumping, and after his feet leave the ground? So before he jumps, it's just his weight. So before he jumps, it is his normal force, or F on P, which is equal to his weight, which is 980 newtons. When he's accelerating, we have mass times the acceleration is the normal force minus mg, which is ma minus mg. So we want to find the normal force. So it's ma plus mg, which is 2287 newtons. So that's the force on the player. And then after leaving the scale, he's not touching it. So his normal force is equal to 0.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
So you're given a free body interacting diagram in your textbook, and you need to come up with a realistic scenario for what's happening. Okay, so first, your free body diagram, you have 9.8 newtons pulling down, 9.8 newtons pulling up, 7 newtons pulling to the right. Let's let these two figures be sitting on top of each other. So for the other free body diagram, you have 29.4 newtons pulling up, 9.8 newtons pulling down, another 19.6 newtons pulling down, 7 newtons pulling to the left, and 21 newtons pulling to the right. So we can let these be acting on each other. Okay, so if we're looking for the sum of all the forces in the y direction, this is going to be equal to 0 because it's not moving in the y direction. So you have the normal force. So if you're looking at this first function, the normal force is 9.8. It's equal to m1g. And we can write Newton's second law for m2. So m2a is equal to F minus F. So if this one's going backwards, this is more than likely friction. And this is a force. So remember that friction is mu times the normal force, which is m1g, because the friction is being caused by the top box. So you get the acceleration is F minus mu m1g over m2. So the force is 21. For this to work, mu would have to be 0.714 based on the friction and what the normal force of N1 is. So this is minus 0.714. The mass of 1, it has to be 1, and then g is 9.8. So you know this mass is 1 because N1 is 9.8. That means M1 is 1, and g is also 9.8. And this is divided by M2 is 2 because of this 19.6 newtons. This is M2g, which is 2g. This is the acceleration. So plugging all of that in, and you get the acceleration is equal to 7 meters per second squared.
हम तक पैसे? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so we have free body interacting systems shown in the textbook, and we want to write a realistic problem, be sure that the answer request is consistent with the diagrams, and finish the solution. So let's just say a 1 kilogram box is placed behind a 2 kilogram box on a steel table. The 1 kilogram box is pushed in the x direction against the 2 kilogram box and released with a speed of 10 meters per second. The coefficient of kinetic friction is 0.6. How long will it take the boxes to stop? Okay, so we can look at equilibrium forces. So we know that N1 is equal to M1G. We also know that N2 is equal to M2G. So mass 1 times the acceleration is negative normal force on 2 to 1 minus the frictional force, which is negative n 2 to 1 minus mu m1g. By that same logic, m2a is n12 minus mu m2g. So we're going to add these two equations together. We get m1 plus m2 times a is equal to negative μg times m1 plus m2. The normal forces will cancel. So a is equal to negative mu g, which we said mu was 0.6. So we get an acceleration of 5.88 meters per second squared. But we want to find a time. So we said the velocity was 10 meters per second. So acceleration is equal to the change in velocity over the change in time. So the time is equal to AdV. We know the acceleration. Ooh, V over A. Sorry about that. So we said the velocity was 10. We know the acceleration is 5.88. So we get a time of 1.7 seconds.
हम तक पैसे? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
100-gram ball of clay is thrown horizontally with a speed of 10 meters per second toward a 900-gram block resting on a frictionless surface. It hits the block and sticks. The clay exerts a constant force on the block during the 10 milliseconds it takes the clay to come to rest relative to the block. After 10 milliseconds, the block and the clay are sliding along the surface as a single system. What is the speed after the collision? What is the force of the clay on the block during the collision? What is the force on the block on the clay? Excuse me. Okay, so first we want their speed. Okay, so we know these are action-reaction forces. So we know that MB AB is equal to negative MC AC. So AC is negative MB AB over MC. We know that the velocities VC final, or sorry, VC equals VC initial plus AC delta T, and VB final is VB initial plus AB delta T. So VC initial plus AC delta T is equal to VB initial plus AB delta T. Since both of those final velocities should be equal, okay, so VB initial is 0. So since VB initial is 0, we get that AC is AB minus VC initial over delta T. We just found an expression for AC. That means negative MB AB over MC is equal to AB minus VCI over delta T. So AB is VCI over delta T times 1 plus MB over MC. And if we know the final velocity is AB delta T, plugging in all of this information, we get a final velocity of 1 meter per second. Part B, the force. So for the force, we have it is equal to MB AB, which is 90 newtons. So for part C, it is also going to be 90 newtons because they are action-reaction forces.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Hello and welcome to this video solution of Numerical. Here you have to calculate the expression for the acceleration of mass m1. Here you have to have the table to be frictionless, right? So here what we see is that the mass m2 is moving down, right? And let's say the weight is m2g is acting down, and here it will be moving down with the net force m2a. That means the acceleration of m2 will be a, right? And this is registered by the tension T due to both this string around the pulley, right? And due to this tension, this mass m1 will move forward. Now you have to understand that since if you just pull this mass m2 with uh, over a distance x, right, then both side will have a distance of x displaced, right, for this string, right? As a result, what happens is this mass m1 will have a displacement of 2x. So that means this mass m1 will move, or maybe the net force will be m1 times 2a. The net acceleration acting on this block m1 will be 2a, right? So this is what you have. Now what you can do is you can simply write down the force equation, which is m2a, that is acting moving downwards, right? It will be equal to m2g minus 2i's t, right? Here t will be equal to m2 times g minus a by 2, right? Now this is equation 1. Now on the other side for block m1, so here you will be having 2m1a, that will be equal to t, right? So this is the net force m1a, 2m1a. and here t can be uh, replaced with m2 times g minus a by 2, right, or 2m1a, that is equal to m2g by 2 minus m2a by 2, right. Or here you will be having a, if you take common, then here you will be having 2m1 plus m2 by 2, right, that is equal to m2g by 2. Or here you will be having a times of 2 4m1 plus m2, that is equal to m2g by 2. 2 can be cancelled, and the acceleration expression will be m2g over 4m1 plus m2, right, is what you have as the expression of acceleration of m1. I hope this is sorry, for m1 the acceleration is twice a, right. Okay, so what you can do is acceleration of m1 is equal to twice a, right, which is equal to 2m2g over 4m1 plus m2. So this is the value of the acceleration. I hope this is clear to you, and have a very good rest of the day. Thank you.
Homework pressure? No more. At String Library, we explain every topic in simple way. Join the learning family and score high every day.
Okay, so we need to find the acceleration of the 2 kilogram block as shown in the figure in your textbook across a frictionless table. Okay, so we have the block. It's connected to a pulley, which is connected to that wall. And there is another pulley. Oh, they messed too. Okay, so looking at this, let's call this distance x1. This distance L1. This is L2. Or let's make L3. This is L2. Okay, so you have tension. You also have the gravitational force, and x2 is pulling down. Okay. That's x2. So to find the acceleration, we have a few constraints. The total length that we are going is L1 minus x1 plus L1 minus x1 because it's this distance twice, plus L2 plus x2 plus L3. This is L. L is also L1 plus L1 plus L2 plus L3. And negative x1 minus x1 plus x2, that has to be equal to 0. So taking the second derivative, so first rewriting, so negative 2 x1 double dot plus x2 double dot, that's the second derivative, and that's the acceleration. So 2 times a1 has to be equal to a2. So we have Newton's second law. 2t is m1a1. m2a2 is equal to m2g minus t. So plugging in for t, we get m2 a2 equals m2g minus m1a1 over 2. So simplifying, and we get a1 is 2 m2g over 4 m2 plus m1. So we know m2, we know g, we know m1. This gives us the acceleration is 3.27 meters per second squared.